Good day, class. For today, our topic is mole concept, and this will give us a deeper understanding regarding counting substances. Here are the learning objectives. First, calculate the substance molar or formula mass. Second, define and describe what 1 mole of a substance is. And third, perform calculations using mole concept. Now, let's start the discussion. So let's talk about the difference between molecular or your molar mass and formula mass. So your molecular or molar mass is being used for your covalent compounds or your molecule. Okay? So this is for your covalent compounds. And if you want to know the mass of a certain covalent compound, the term that you have to use is your molecular or molar mass. Now, for ionic compounds, the term that we have to use for the mass of ionic compound is formula mass. And in order for us to calculate that, we have to use this basic rule. Molecular and formula masses, we can compute that by adding the atomic mass of the elements in the compound, each multiplied by the number of atoms of individual elements. That's the reason why we need to use the periodic table of elements in order to properly do the said rule. Again, molecular or molar mass is for your covalent compound, while for your ionic compounds, we use the term formula mass. Though they have similar rule in terms of calculation, but be mindful about the term being used when it comes to your covalent or your ionic compound. Now, let's have an examples to further deepen our mathematical understanding regarding these concepts. Now, as mentioned earlier, we'll be using this periodic table. So, wag malilito. Hindi ito iba sa periodic table that you've already observed and used. What makes it different is that values here are for the atomic masses of the elements here. Okay, and we'll be using that in order for us to properly compute the formula mass or the molecular mass. So let's have an example. This is the first example. What is the molecular mass of carbon dioxide? CO sub 2 with this chemical formula. So molecular mass is the term used because we're dealing with a covalent compound. This is covalent compound, your carbon dioxide. So the first step that we have to do, we have to determine the number of atoms of the elements present in this compound. So our compound is your carbon dioxide. So we have to look on the subscript in order for us to get the number of atoms of the elements present in this compound. So for carbon, we have how many? We have 1 because there's no number, okay, number present here. That means the value or the number of atom for your carbon is 1. Now for oxygen, you see a subscript which has 2. Therefore, the atomic or the number of atom for oxygen in this compound is 2. Okay, so hopefully you're following that one. Now, the next thing that we have to do is we have to find the atomic mass of each of this element. Okay, using the periodic table of elements, which is this one. Let's go back to this slide. So we're looking for the atomic mass of carbon and oxygen. For carbon, 12.01, and for oxygen, 6.00. You can actually screenshot this one para alam nyo na yung madali na lang sa inyo to get the atomic mass. Pero if you have a physical periodic table of elements, naka-indicate naman doon kung saan yung mga atomic masses. Okay? So, let's copy the atomic masses of carbon and oxygen in order for us to continue solving this. So, your carbon has 12.01, and for your oxygen, it has 16.00. Now, in your periodic table of elements, baka hindi yan 12.01 or marami pang values yan. Okay? Here, the reason why I'm using that kind of periodic table para may uniformity tayo, and our final answer must always in 2 decimal places. Okay? So, always in 2 decimal places tayo for computation. Now, we're done with finding or determining the number of atoms of the elements. We're good with finding the atomic masses of each atom or each of your element in the compound. So we have to multiply this we have to multiply the mass to the number of atoms. Yun. Okay, so we have for carbon, so 1 times 12.01, and for your oxygen we have 2 times 16. Okay, so this is another technique that you can do other than this one para tuloy-tuloy ang pagko-compute. So is equal to, for this one, 1 times 12.01, that is 12.01 also. Now for oxygen, 2 times 16.00, that is 32.00. So after multiplying the atomic mass to the number of atom, we have to get the sum of the product. Okay, so we have to add this one. So add this, we have 0.01. So 12 plus 32, we have 44.01. The unit that we have to use is AMU. AMU means atomic mass unit. Okay, so this is the typical unit that you can see from your periodic table of elements, or we can actually denote it as, in other reference material, they denote it as small letter u. So that is still AMU, atomic mass unit. So our molecular mass for carbon dioxide is 44.01 AMU. Okay, so hopefully you follow the steps properly. Now let's have another example. So we'll be using the same periodic table for the atomic mass. What is the formula mass of sulfuric acid with this chemical formula H sub 2 SO sub 4? So this is an ionic compound. Okay, kaya formula mass. But the steps in computing formula mass is just the same with your molecular mass. So we have to identify first the number of atoms of the elements present in the compound. Yun yung unang step, and then we have to get the atomic mass of each of the element, then multiply that to the number of atoms, then get the summation of it. The product of we have to get the sum of all the product. So I'll be using this technique para tuloy-tuloy. So for hydrogen, just copy lang the formula H sub 2 SO sub 4. For oxygen, we have how many atoms? 4. For sulfur, there's no subscript. This is just 1. And for hydrogen, there are 2 atoms. Okay? So we have to multiply this to their corresponding atomic masses. Okay? So we have to look on the periodic table. Okay? So we have to look for hydrogen, sulfur, and oxygen. For hydrogen, we have 1.008. So, 2 decimal places lang tayo hanggang 1.00 lang tayo, class. And for your sulfur, 32.06. And for oxygen, 16.00. So, we just need to copy that. So, for oxygen, just follow the arrow para hindi tayo naliligaw. Oxygen, we have 16.00. For sulfur, we have 32.06. And for hydrogen, we have 1.00. So multiply that. So for 4 times 16.00, we have 64.00. And for 1 times 32.06, just the same. And 2 times 1.00 is just 2.00. Now we have to add this all. And our answer for the formula mass of sulfuric acid is 98.06 ANU. So hopefully you follow this one again, no? So madali lang naman. Now, third example, and the last example, we'll be using again this periodic table of elements for the atomic masses. So calculate the formula mass of saltpeter with this chemical formula KNO sub 3. So formula mass because this is still an ionic compound. So copy the chemical formula. So identify the number of atom per element here. So for oxygen 3, for nitrogen 1, for potassium 1 as well. Okay, so let's take a look on the periodic table to get the atomic masses of your potassium, K, 39.10, and for your nitrogen, 14.01, and for your oxygen, which is 16.00. Okay, so copy that, and we have to multiply that to the given number of atoms. So oxygen 16.00. For nitrogen, we have 14.01. For potassium, we have 39.10. So multiply that. 3 times 16.00 is 48.00. So this is just 14.01, and this is just 39.10. So add this. We have 101.11 AMU. So this is now the formula mass of saltpeter, which has this chemical formula NO sub 3. So let's talk about the mole or mole. So in life, we keep on using counting units to easily represent the quantity of materials. Like with your 1 dozen for 12 eggs. Or even in 1 pair of shoes, that is lead us to having 2 shoes. A pair is equal to 2 pieces, or a dozen is equal to 12 pieces. In chemistry, mole is simply defined as the quantity of a substance which contains the same number of particles. Therefore, mole is a unit to count numbers of particles. And that is equal to, 1 mole is equal to 6.022 times 10 raised to 23. Like with what I mentioned earlier, a dozen means 12 pieces. A pair means 2 pieces. Now, for chemistry, 1 mole means 6.022 times 10 raised to 23. Now, to give you examples, if you have 1 mole of table salt, that gives you 6.02 times 10 raised to 23 sodium chloride, or your table salt. Now, for 1 mole of gold, that gives you 6.022 times 10 raised to 23 gold atoms. Okay, now if you have 1 mole of sugar, that is 6.022 times 10 raised to 23 sugar. And if you have 1 mole of water, that is still 6.022 times 10 raised to 23 water molecule or water molecules. Now, to simplify everything, your 1 dozen, which is equal to 12 pieces, your 1 pair that is equal to 2 pieces, is just the same in terms of concept with your 1 mole. Whatever substance we are referring to, 1 mole of that is equal to 6.022 times 10 raised to 23. And that value, or that particular value, is known to be the Avogadro's number. Okay, so this is known to be the Avogadro's number. And also, mole is the amount of substance that contains as many as elementary entities. It could be atom, particle, molecule, as there are atoms in exactly 12.00 grams of carbon. So the actual number of atoms in 12 grams of carbon 12 isotope is equal to this value, equal to your mole value, which is 6.022 times 10 raised to 23. And the reason why it was named Avogadro's number in honor of the Italian scientist known to be Amadeo Avogadro. Okay, so again, 1 mole is just equal to 6.022 times 10 raised to 23. So that is a unit to count numbers of particles in chemistry. Now, in order for you to easily solve problems related to mole concept, and in order for you to use that Avogadro's number properly, we're using this map. This is known to be mole map. Again, this is known to be mole map. This will lead you to the proper ways on how to do dimensional analysis for converting mole to particles, mole to mass, mass to mole, so on and so forth. Okay? So this will give you as well the operations that you have to do in order for you to properly compute certain values that are unknown in a given problem in relation to mole concept. Sige, let's apply this mole map. Now let's have an example. So we have, for number 1, common table sugar, sucrose, with this chemical formula C sub 12 H sub 22 O sub 11 has a molar mass of 342.0 grams. What is the mass of 0.15 mole of sucrose? So we'll be using this mole map para we know the direction of our entire, we know how to solve properly this given problem, and this will give us the right direction in terms of dimensional analysis. Yun yung gustong sabihin ni sir when it comes to the mole map. And also, we're going to use the Gressa method. This will help us to easily present our solution ng hindi magulo. Okay? So G means given, R means required, or for that, that is for the unknown, E is for the equation, and S is for the solution, and A is for your answer. So let's begin with G, the given. So from the problem, based on this, we have the value for the molar mass, or the molar mass of your sucrose, which is your C sub 12 H sub 22 O sub 11. Molar mass simply because sucrose, or this formula, this compound is known to be a covalent compound. So hopefully nasusundan pa rin yung tinuro ni Sir kanina. So that value is 342.0 grams. And the value for the mole, our mole value is for our C sub 12 H sub 22 O sub 11 is 0.15. Okay, and we are asked to compute for the mass. Kasi what is the mass of this mole of sucrose? So small letter M, or mass, that refers to mass in grams. And for our equation, we're going to use this mole map para alam natin yung dimensional analysis for us to compute it properly. So our given is mole, and that will lead us to finding the value of grams. So that's how we use this mole map. So we're going to use this a way to properly solve this problem as our equation. Okay, so mole multiplied to your grams over 1 mole. Okay, saan po galing yung 1 sir? Dito yan. Okay, to your mole map. So substituting the given, we have for our mole, we have 0.15 mole. Okay, of multiplied to your the grams here, that came from the molar mass of your sucrose, which is 342.0 grams, divide by your 1 mole. Okay, so cancel similar units. So that's yung rule na tutunan natin in mathematics, so that your remaining unit is grams, and that refers to the mass of the mass, which is for the unknown. Okay, so do the math here, use your 0.15 mole, multiply that to 342.0 grams over 1, or divide that to 1. The answer is 51.3 grams. So this is the mass of your sucrose with a mole value of 0.15. So hopefully you follow how we properly compute it using GRESA, and how we identify the right dimensional analysis using the mole map. Now here's the thing, class. There are instances that the molar mass is not given in the problem, but luckily we have molar mass for your sucrose here, which is your 342.0 grams. So what you're going to do if there's no molar mass is for you to solve for the molar mass. Paano yun, sir? Look on the formula, follow what I taught you earlier when it comes to getting the value of the molar mass, or the molecular mass, or the formula mass. No? Paano yun, sir? You multiply the number of atoms of each element to its corresponding atomic mass. Yun lang naman yun. Then add all the products. So that leads you to the formula mass or the molecular mass. So since we have molecular mass here, good tayo, no? Okay? So that is for problem number 1. Now let's have another example para mas lumalim ang pag-intindi natin when it comes to mole concept and how can we properly use the mole map. So let's have number 2. If there are 0.350 moles of P sub 4 molecules, okay, so A, how many P sub 4 molecules are present? B, what is the mass in grams of the sample, which is your P sub 4 molecules? And letter C, how many P atoms are present, or phosphorus atoms are present in the molecule, okay, having that 0.350 moles. Still, we're using this mole map para we can properly know the right dimensional analysis to be used in each of this question. So, GRESA pa rin tayo para mas maayos. Let's start with letter A. So how many P sub 4 molecules are present? So our given is your 0.350 mole of P sub 4. Okay? And we are asked to compute for the number of molecule. Okay? And for our equation, tingnan natin yung mole map. Our given is mole. So, tingnan natin yung direction. Where are we leading to when we use this mole map? So, mole is the given. We're looking for molecules. Okay? It could be molecules, particle, atoms, so on and so forth. Okay? So, therefore, our direction is moving towards this one. So, we'll be using this as our dimensional analysis for this problem. So, mole multiplied to 6.022 times 10 raised to 23. That is your Avogadro's number, N sub A, your Avogadro's number over your 1 mole. Okay, wag malilito. N over A is just your Avogadro's number. That is equal to 6.022 times 10 raised to 23. Constant yan. Okay, so for our solution, substitute lang 0.350 mole multiply to 6.022 times 10 raised to 23 over 1 mole. Cancel similar units. So using your calculator, this is how you will compute for this problem. And now for our answer. So our answer is 2.11 times 10 raised to 23 molecules. Okay, so molecules is our unit because that is what we're looking for. And 2 decimal places ang final answer natin. Okay, wag malilito. We just simply round off yung number. Okay, kasi more than 5 yung katabi niya. In order to have this 2.11 times 10 raised to 23. Now, for letter B, let's see. What is the mass in grams of the sample? Still same given. 0.350 mole of your P sub 4 molecule. And we are asked to compute for the mass, which is in grams. And our equation, if given natin ang mole, ang direction natin is pa grams. So, we're using this as our dimensional analysis. Okay? So, mole multiply to the grams here over 1 mole. Since wala tayong grams na given, okay, hindi naman natin mako-compute yan without having the grams. So, the value for the molar mass. Molar mass kasi nga this is a covalent compound or molecular mass. So, we have to get the molecular mass. Okay, and we can do that by multiplying the number of atoms to its atomic number. So, we have P sub 4 multiplied to, let's take a look on the periodic table for the atomic mass of your phosphorus, 30.97. So, 30.97 times 4. Our answer is 123.88. Okay, so this will become the value for the molecular mass in order for us to properly compute this problem. So, 0.350 mole multiply to your 123.88 grams over 1 mole. Our answer now is, okay, we're just simply doing the math thing here. So our answer is 43.36 grams. Okay, so that is the mass of the sample having this given, which is 0.350 mole of PSAP. Okay, so hopefully nasusundan, no? Nasusundan. Kaya this is important. The mole map is important, and the concept you've learned earlier is also important in order for you to get another values, especially for the molecular mass or the formula mass. Sige, last tayo, letter C. I'll just erase this solutions. Now, for letter C, we are asked to compute for the number of atoms present. So, yun ang ating required. Same given pa rin tayo. Kasi, same problem pa rin naman tayo. Okay? So, number of atoms. Now, tingnan natin yung mole map kung saan tayo direction titingin para tama ang dimensional analysis natin. Mole ang given, number of atoms. So, dito yon. So, pag ganitong direction tayo, so we're going to use this one. So, you've observed that parehas lang ng ginawa natin sa letter B. So, same answer lang din ba yan, sir? No. Bakit? Kasi we're after with atoms. And how many atoms are present in the molecule for your P sub 4? 4, right? So, what we're going to do as our equation is to add the value of or the number of atoms in your equation. So, how can we do that, sir? So, mole multiply to the Avogadro's number over 1 mole. So, since atom yon, so ito yon, yung unit nito ng ating equation is atom. So, we have to multiply the Avogadro's number to 4. Okay, before we multiply it to the value of mole and dividing it to 1 mole. Okay, saan po galing ang 4? That came from the number of atoms present in the given molecule, which is your P sub 4. Okay, so hopefully nasusundan si sir. So for our solution, so substitute lang natin 0.350 mole multiply to 4, open close parenthesis, the value of your Avogadro's number, 6.022 times 10 raised to 23 atom, okay, over 1 mole. So, cancel similar units. So, let's do the mathing here. So, using your calculator, this is how you will enter the values. Our answer is 8.43 times 10 raised to 23 atoms. So that's the number of atoms present in the given molecule for your phosphorus. So this is our final answer. And hopefully you follow the entire procedures on how we solve problems in relation to mole concept.